Hello class, today we're on 5.4, the indefinite integral. So up to this point, when we were talking about integrals, we have been talking about the definite integral, where we integrate the function and then we evaluate at different endpoints. The difference between the definite integral and the indefinite integral, though, is that the indefinite integral doesn't have endpoints. So we're just talking generally, what is the general integral for this function? Now, here's the trick. When finding the indefinite integral, we always need to add plus c. Because think about it. Well, and the c stands for constant. So think about it. If we were to integrate, or if we were to take the derivative of a function, the constant goes away. Now, when we go backwards, we need to account for any possible constant that went away. It could have been plus 500, it could have been plus 1 million, or it could have been plus 2, right? But that goes away, so we need to account for that by saying plus c, plus some constant, and it's an unknown constant at this point. So, looking at the first example, we take the integral just the exact same way. We're getting hopefully pretty good at doing the inverse power rule. So let's integrate this. So the indefinite integral of this, well, let's see. Remember, we raise the power and then divide by that power. So this would just be x to the fourth. This would just be x cubed. Right? We raise the power to 4, divide by 4, we just get 1. Raise the power to 3, divide by 3, we just get 1. And this is just going to be x squared, right? We raise to the power of 2, divide by 2, get 1. And then plus, this 1 is an x, but we need to add plus c, just like that. Because when we took the derivative, or if this was our original function, and say we had a plus 10 here, well, that would go away, right? But we don't know if there was a constant. It could have just been plus 0, right? But we need to account for those. So let's go on to the next one. Let's see. We want to find the integral of sine of x minus 6x squared dx. So the integral of sine of x is negative cosine of x. And then, let's see, minus, what do we have here? We're going to raise the power to 3, and then divide by 3. So 6 divided by 3 is 2, so it's going to be 2x cubed plus c. And we're done. All right, let's do a couple more examples. This is a pretty easy lesson. I mean, we've already done integrals before. The important thing is just that plus c that we're missing, or that we haven't learned about before. So let's see here. We want to integrate this. So the integral of e to the x is just e to the x. We like working with that guy. Let's see here. Raise the power to 3 and divide by 3. So 12 divided by 3 is 4. So it's going to be 4x cubed. And again, you can always verify after the fact, right? By imagining or taking the derivative, right? This times 4 is going to give us 12, and then lower the power, 12x squared. Okay. And then this, raise the power by 1, so it's going to be x squared. Divide by 2, that's going to be 3x squared. Oh, and then plus c, just like that. All right, this last example here, we want to take the integral of 10x to the fourth plus 9x squared plus 5 dx. So let's see here. Raise the power by 1 and divide by 5. So that's going to be 2x to the fifth. Here we're going to raise the power by 1 and divide by 3. So that's going to be 3x cubed. And this guy gets an x. And we need our constant plus c. And that's it. So that is the definite integral. I hope this video helped, and just always remember, don't forget your plus c's. Bye.